Welcome. In today's video, we'll explore the backbone of modern building management systems, networking and communication. Whether you're a facility manager, engineer, or just curious about smart buildings, understanding how devices, controllers, and servers talk to each other is crucial. We'll break down the two main communication layers, serial protocols like RS-485 and IP Ethernet-based protocols. By the end, you'll know how these networks operate, where they're used, and how to design and troubleshoot them for reliability and security. Let's get started by looking at the overall architecture of BMS communication. Building management system is structured in layers, each with its own devices and communication needs. At the field layer, you'll find sensors and actuators collecting and acting on data. The controller layer uses DDCs, direct digital controllers, communicating over RS-485 or IP. Above that, the supervisory layer hosts BMS servers and workstations, often connected to the cloud. Finally, the integration layer brings in gateways, fire panels, energy meters, and SCADA systems. This layered approach ensures efficient data flow and system scalability. Next, let's dive into how serial communication works in BMS. Serial communication is the traditional backbone for connecting BMS field devices. It uses twisted pair cables, typically following the RS-485 standard. This setup is ideal for short distances and a limited number of devices, making it perfect for connecting sensors, actuators, and controllers on the same floor or building zone. Serial protocols like Modbus RTU and BACnet MSTP are widely used, each with its own strengths. Modbus RTU is open and simple, while BACnet MSTP uses a token-based approach for reliability. Let's see what makes these protocols unique. Let's compare the most common serial protocols in BMS. Modbus RTU is polling-based and easy to integrate, making it a favorite for many device manufacturers. BACnet MSTP, on the other hand, uses a token passing method, which helps prevent data collisions and ensures smooth communication. Other protocols like KNX and LonWorks are also used, especially in lighting and legacy systems. When designing RS-485 networks, remember, limit each segment to 32 devices, keep cable runs under 1,200 meters, use shielded twisted pair cables, and always terminate both ends with resistors. Consistent settings across devices are key for trouble-free operation. As buildings become smarter, IP-based communication is taking center stage. Here, devices connect over Ethernet LANs or WANs, each with its own IP address. This allows for faster data transfer, scalability, and easier integration with IT systems. Common IP protocols in BMS include BACnet/IP for controllers and servers, Modbus TCP for meters and analyzers, and HTTP/HTTPS for web-based dashboards. SNMP and MQTT are also used for IT and IoT integration. Proper IP network design, like static IP assignment, subnetting, VLANs, and security, ensures reliable and secure BMS operation. Most real-world BMS installations use a hybrid approach, combining serial and IP communication. For example, sensors connect to controllers via analog, digital, or RS-485 signals. Controllers may talk to each other using BACnet MSTP or Modbus RTU, while communication with servers happens over BACnet/IP, Modbus TCP, or HTTP. Clients access the system through web interfaces or workstation software. This layered, hybrid setup allows for flexibility, cost savings, and future expansion. Next, let's see how gateways and protocol converters help different systems work together. In BMS, not all devices speak the same language. That's where gateways and protocol converters come in. These devices translate between protocols, like converting Modbus RTU to BACnet/IP or KNX to BACnet, so that all systems can communicate seamlessly. For example, integrating a Modbus RTU energy meter with a BACnet/IP BMS server requires a Modbus to BACnet gateway. Fire panels, lighting systems, and other third-party devices often need similar solutions. Proper gateway selection and configuration are essential for smooth integration and reliable data exchange. Addressing is fundamental in BMS networking. Serial protocols use device IDs or slave addresses, like Modbus addresses from 1 to 247. IP protocols rely on IP4 addresses and sometimes port numbers, such as 47808 for BACnet/IP. When issues arise, tools like Modbus scanners, BACnet browsers, Ping, Traceroute, and Wireshark help diagnose problems. Checking LED status lights can also reveal physical connection issues. Consistent addressing and using the right troubleshooting tools ensure quick resolution and system reliability. Increasing connectivity, cybersecurity is more important than ever in BMS networking. Always isolate BMS networks from office IT networks using firewalls and VLANs. Disable unused ports and services, enable encryption, and enforce strong authentication. Regularly update controller and server firmware to patch vulnerabilities. These steps protect your building's critical infrastructure from cyber threats and ensure safe, uninterrupted operation. Let's wrap up with a summary of key points. Sum up, efficient BMS networking relies on understanding both serial and IP protocols, designing networks with the right topology and addressing, and following best security practices. Whether you're connecting field controllers over RS-485 or integrating servers via Ethernet, careful planning ensures stability, scalability, and interoperability. Remember to use gateways for protocol conversion, assign addresses consistently, and always prioritize cybersecurity. Thanks for watching. Now you're ready to design, troubleshoot, and secure your BMS networks with confidence.